an infinite number of times since it goes up and down forever. Okay? This is sort of an epic fail of the requirements of a function. It's about as much a non-function as I can possibly imagine. Yes?
Why, when you spelled it up there, you put an X and now you put Y?
Oh, what I've done here, excellent point. It's not a spelling, it's the variables.
Oh.
Okay? This says, I'm actually really glad you asked that. This says I'm putting X's in and the Y's are coming out in this pattern. And you'll learn more why that is in the spring. This says I'm putting Y values in and the X's are coming out in this pattern. Okay? I've switched the input and the output.
Mm-hmm.
And that's the definition of inverting a function, which we'll also get to in the spring.
See.
Yeah, this refers to the variable X and the variable Y. What I've done is X is the independent variable here.
Then why do you have X equals?
Well, I've switched them. And when you switch them, that makes graphs that go sideways go up and down. We will get into that in the spring. I'm jumping way ahead conceptually. All I really want you to get from this is the function idea. And I want you to just sit in frustration until we get back to this in the spring. I think you're good at that, Amy. I think I've given you enough information. Oh, last thing. I need to define two terms that I hope you heard in Algebra 1, just to make sure that you see them. First thing is, there's no trick questions in the homework tonight. If you're given a graph of a shape you've never seen before like that, it doesn't matter that you don't know how to make that graph. You just have to answer some simple questions about whether or not it's a function based on what we've discussed today. Okay, there's no effort to trick you or, it's not supposed to be fancy. Same thing with this. You might be asked in the homework tonight about the domain of a function or the range of a function.
Yeah.
Who remembers what these might be? Sarah? X and Y. That's the short answer is domain is X's, range is Y's. May I expand on that definition a little, Sarah?
Yes.
Okay. The domain is all the X values for which a function exists. The range is all the Y values for which a function exists.
So it's the exact same definition, but in...
Well, yeah, domain is like, what did Sarah just say? Domain's X and range is Y. Okay? Domain is input. Excellent. Range is output. Domain and range are actually some of the few math terms where I've never bothered to try to look up why X is called domain and Y is called range. Those other math terms, I get curious about where they come from. I don't know why. Range, I don't know why don't call it range of X and range of Y, actually.
Is it possible to have two outputs?
Once you get to college and take multi-dimensional math courses, yes.
No,
where you have like an X, Y, and a Z axis.
There's a Z-axis.
Apparently.
Yes. This is
Wait,
a
what
short
does the
answer.
Z-axis look
But
like?
not in any way that... we will get to that, believe it or not.
Really?
No, I don't want to get to that.
Yeah, real quick thing on domain and range before I answer Jordan's seriously metaphysical question.
Would you ask?
Okay, domain and range notation. Real quick, parentheses means included. Bracket means not included. And here's what I mean by that. If I just give you a picture of a line. This is a line that goes on forever from left to right. Okay? If I want to write its domain, it looks like its domain is forever, right? It goes on and on to the left and right forever. Okay, here's how we write that. We say that this thing starts at negative infinity on the x-axis, because if I write domain, we're talking about input or x. So I say this starts at negative infinity. Here's what negative infinity means. As far to the left as I can imagine. Okay? You don't include infinity because it's not a real number. So you have to use the bracket. I think this line goes as far to the right as I can imagine. So I write to positive infinity. That's our basic definition of infinity this year. Negative infinity is as far to the left as we can imagine. When we're talking about domain, positive infinity is as far to the right, and you don't really include it.
What do you mean by include and not include?
Get to that in a second. Okay, let me go with me for a second on this one, and this next example I think will make that clear.
It's very confusing, man.
Range, this line will keep going down as far as I can imagine, and then up as high as I can imagine.
So it never stops.
So it never stops. So I'm going to write that as negative infinity to positive infinity as well, but since we're talking about range, I'm talking about from way down here to way up here. Okay? Now I'm going to go back to my circle. I'm going to draw a circle with a radius of 1.
That must be a small radius.
Well, yeah, but I'm going to scale it so it's not that small. 1 is going to be that big. I apologize for the quality of my circle. That's a terrible circle. It's more of an egg. Pretend with me, okay? This is 1. This is negative 1. This is 1. This is negative 1. The domain of this, even though it's not a function, okay, is still going to be from the left to right. It starts at negative 1, and it does exist at negative 1. So I use a parentheses because it does exist there. It goes over here to 1, where it stops existing, but it does exist at 1, so I have to use parentheses. How far up and down does this circle exist? 1. It goes from negative 1 to 1. Okay?
So if it never stops, it's brackets?
No, it's a little weird. If it's not included, it's brackets. And the included is going to be a little bit hard. We're going to fiddle with that a little bit. What else is not included?
What do you mean? I don't get it.
Basically, if it's infinity, it's brackets, and if it's a number, it's parentheses. For I think all the examples we're going to do. Okay?
So you're saying, okay, never mind.
Okay, it's about to end. There's one more thing about domain and range I wanted to say, but real quick, just this parabola here. Okay? How far do you think this thing goes from left to right?
It never stops.
Right.
Unless
Never stops. This is the notation we'll use. I'll try and come up with some better examples for brackets and parentheses tomorrow. Don't think it should slow you up too much in the homework tonight. For range, where does this thing exist from?
Never stops.
Never stops going up, but does it go all the way down to the bottom as far as you can imagine?
Zero.
Starts at 0, and it does exist at 0,
So it is included.
and then it goes up to infinity. Where we put the bracket. Okay? For the domain and range of a data set, like the individual data points I put up here, the domain is just all the x points, the range is just all the y points. Sorry I don't have time to write that, or do a better example of that one. But you know what I mean? Like if you're just graphing the points, the domain is the x's, the range is the y's. That way you can, for that one, just use Sarah's simple definition. Domain is x's, range is the y's. Okay, does that make sense?
Yeah.
Homework is online. I believe it's accurate. Cut.
Do I just push the red?
Just push the red button, yeah.